So cataloging. Uh, this is going to be a dual kind of an agenda. Want to talk about technology as well as the mindset that goes into developing a cataloging kind of a system. We all know how local Kirana stores work. So let's see if I have to develop a virtual Kirana store, what kind of a thought process I will go through. Before we start, differences between being an artist versus being a scientist. Artists, the trends that you associate with an artist, they're very imaginative. They're creative, they're unbounded, they're free form. Scientists, they follow a very measured approach. They're formulative, they're methodical, and they most of the times work against set patterns. It's difficult to deviate a scientist from established patterns. So let's try and define cataloging. Let's go by the dictionary meaning first. Catalog. Catalog is a list or itemized display, usually including descriptive information or illustrations. And what is cataloging? Cataloging is the process by which you list or include items in a catalog, or you classify according to some categorical systems. How do we define cataloging pertaining more to the e-commerce world? Cataloging is the process of managing the inventory of products through the entire life cycle of creating, updating, provisioning, deprovisioning, and finally deleting the product. And why is the problem interesting? Anyone here from a non-Flipkart background who may have worked with some catalog stores? Okay, so why is the problem interesting? Maybe I'll put in some more context around cataloging system within Flipkart. Our growing size. Amod also pointed out that the catalog size for us is close to 18, bigger than 18 million products. That's a huge size, and it constantly grows because business is expanding, sub-businesses keep evolving. So size is basically a tenet that poses an interesting problem to us. Then the dynamic nature of the metadata. The metadata is very, very elastic. Today, I associate certain semantical meaning to a product. That semantics may change, and I keep on adding many more semantics. I may start off with just a size with a product, size attribute to a product. In future, I can get variations in terms of colors or in terms of how the packaging is done. So you keep on adding much more semantic to the product that you started off on day one. So elasticity is under trait that you need to keep in mind. Then association between data elements, which translates to flexibility. We'll go into deeper discussions around what flexibility means. Data elements could be anything. You start off basically with a product biblio, which is just an illustration or a description about a product. Then there is the sizing associated with it, the pricing, compliance, associations like who is the contributor, who is the author, who are the suppliers. So there are so many associations that you start off with, and associations keep on building over time. A trivial example, you sell a book as a standalone book on day one, and later on, the book is part of a compilation. So that's a new association I've formed on say, 6 months since I went live with that book. Compilation could be based on a genre or a year or by author. So this is a new association that I formed. And going down the line, there could be many more associations that get built. So I need to keep flexibility into account. Then flux of changes, variability. Trivial things like pricing. Pricing may change on a day-to-day basis, on a weekly basis. The inventory goes up and down for physical commodities. So there are a lot of variations associated with any product that you can think of. Then it's a huge SOA-based infrastructure. Cataloging is one part within it. You have supply chain elements interacting with it, order management, so to say, warehousing, inventory. These all systems, in some way, add on to the catalog definitions. It could be compliance, it could be accounting, it could be inventory update, decrease. So sooner or later you find out that data, because of decoupling of systems, is is just distributed everywhere, and we might have a lot of duplicate data, churned out across systems. We need to seriously start thinking about data partitioning, data compression, and data ownership. That again poses more like an engineering problem to us. How do we solve it? So this is more of a mindset change in addressing any issues regarding building these systems. So what we need to do, be very comprehensive. That's a scientist mindset. But still be imaginative, which is an artist. Be methodical, yet be flexible. Work with patterns, but never bound yourself to patterns. Think of new patterns that can help solve your problems. Be a composer, be an artist, blend wherever required. No single solution fits all your requirements. So think of an artist who can play around with multiple colors. So with that mindset, let's start solving the cataloging problem. So what are we beginning to solve? So these are the various steps that you need to go in order before you address building that system. You need to start with identifying the basic data elements that form a catalog for you. Identify relationships between the data elements. Identify the usage patterns, basically which are the different systems going to interact with your catalog and in what way. Create an ideal representation, which is the logical model. So catalog system itself is a data store. Characterize it before you dive deeper and build technology solutions around it. Architect the catalog data cluster. I'll introduce you to the concept of catalog data cluster in one of the slides, and define views or interfaces on top of it. So identify data elements. Product biblio is the basic element in a catalog. What actually goes into describing a product. The basic traits. Then you start thinking about product variants, the stock attributes, category, product images, supplier, pricing, contributors, taxation, product sellers. So these are different basic elements that together help you build a catalog. So question to you guys, which among these blocks is the most important for you? Sorry? Price? For me, that is still an engineer speaking, so I want to go beyond an engineer. Mm-hmm. Sure. Fine. Great. So that adds the comprehensive part of it. But for me, the best building block here out is the question mark. I want to keep my scope flexible, adaptive. I don't want to restrict myself to the comprehensiveness as of now. For me, it's a question mark that I'm provisioning for additional data elements as time goes on. So yes, be comprehensive, but be imaginative that yes, tomorrow or day after, there are new data elements that are to be introduced, and then you are not restricted by the choice that you made today. Second step, you found out data elements. Let's start relating the data elements together. A trivial example of a book. Book is a physical product. Book belongs to a year. Book belongs to a genre. Books belongs to an author. And if I come up with compilation of books, then compilation has a reverse relationship. Compilation has a relationship to a book. So think of generic relationships. I do not want to start on day one that a book has an author. I do not want to make these elements as relationships. Relationships should be much more abstract, generic. You start thinking of containment, associations, is a, has a, belongs a. So in those paradigms, you can fit in additional relationships, additional associations in future. So again, be comprehensive and be imaginative. Let's start looking at the data query patterns. Is the querying real time or offline? And when we say real time or offline, this is from a customer perspective. So there is a buying behavior, there is an online processing being done as the customer is making purchases or browsing through the site. So is that activity required to be done real time, offline? That's a decision that you start making early on. Is the query ID based? there are identifiers with data elements. Are you querying using identifiers, or you're making use of ad hoc filters? Is a query linking multiple data elements? Understand query SLAs at ever increasing scale. So website may, on day one say that, okay, I don't have enough volumes. I can give it the luxury of serving me the data in say 100 milliseconds. As time goes on, as traffic increases, as catalog size increases, the stringent SLAs come into play. They now start demanding a 50 millisecond latency from me. So I need to be savvy about what SLAs I'm serving. Then question the client. Why is the client writing such a query? I am maintaining the entire catalog. There is a complex join that they have written to query the data from me. Is that aggregate really required? Can they get the data in buffers, in batches? So keep on questioning them. You should not just go by the heuristics that they follow. Maybe you have organized data better. You have a better structuring that is suited for certain kind of queries. Educate them. So example of queries could be book with a specific title like Secret of the Nagas. Books by Chetan Bhagat published in 2012. Here I'm beginning to introduce more filters. There's an year filter that has come by alongside an author. Then it may grow much more ad hoc and much more verbose. Books which are thrillers, which is a genre, published post 2005, written in Hindi and published by Rupa Publications. So yeah, here I start to see lot many filters coming into play. Have I devised my catalog in such a way that I can serve out any ad hoc filters? So understand that part too. Then how do we just mentioned that queries could be ID based? How do I identify data elements? It's non-trivial. Again, the examples of book. Day one, I think title is good enough. But there are multiple publishers that can come up with the same title. So day two, I say, okay, title per publisher makes sense. I'm introducing some variability. There's a flux here. Then the book has now started coming up in multiple editions. So again, you make changes to the identifier. So keep these things in mind, because the choice of data store or how you implement or structure the data becomes important, because you are trying to imagine, you're not just accepting the facts as they come. You have to forecast the facts. Now, the book has multiple variants. There could be a paperback edition. There could be a hardcover. Who knows? So again, the important part is the question mark. That identification or any such scheme, any such rule that you assume on day one is only true for a certain period of time. It needs to change. So this is the semantic part of it, that there is a semantics associated with the data. You should have the ability to be an artist, be imaginative, forecast, and just be flexible enough to adapt to any changes in the future. So just like an artist with a brushstroke, be a scientist, but with a brushstroke in hand, that you are free form. You are actually trying to vent your mind in different directions as you build systems. So let's start with the input so far. Let's start building a logical model. Let's see how a logical model can take different shapes. A traditional way to start with, schema-based approach, where there is a form and structure to everything on day one. So if you are from a relational database background, you should be able to relate to it, that every possible data element or entity is a table. Then relationships are mirrored through constraints. Queries are supported through indexes and joins. Typical MySQL kind of queries. So what are the advantages? What are the plus? There is a richer query support. There is built-in support for relationships. The indexes that help you write optimal queries. But what are the drawbacks? It's not very elastic. If I'm working against a data form where I'm adding, deleting columns at will, almost every week, then is relational database helping me enough? There is a column C1, I drop it. Tomorrow I added C2, then drop it, C3, keep on altering the columns. And even for identifiers, I start off with a primary key or a composite key. That keeps on changing. With the book example, how often will I, unload the index, reload the index, and it's really taxing with the kind of volumes that we are dealing with. So elasticity is a big concern when dealing with catalogs. And it's not optimized for some of the use cases. If I'm just dealing with some key value pairs, is MySQL an overkill? Or I'm dealing with just huge chunks of data which are just to be randomly accessed. Or I'm doing some kind of a graph traversal with the data elements. Is MySQL good enough? No. So typical examples of schema-based approach, mostly it's relational databases. We all know about MySQL, Oracle, Postgres and all. So this is the first step. This is the traditional approach. But in cataloging, we start thinking flexibility. We start thinking beyond the traditional data stores. Let's take the next step, a semi-structured or semi-schema kind of an approach. Here, we are talking about blobs of data, documents of data. Then documents are linked to each other because we want to still stick to some kind of relationships, associations. How are queries supported? Queries are supported through document identifiers. Each document that you build has an identifier, has a reference. If you know the reference, you are able to look up the document. And document references help you link together documents which are related. What are the advantages? There is some kind of a flexibility that you have built in. So documents are less rigid. So within the document, you can have any kind of a structure that you want to impose. You can have a JSON structure, you can have a BSON, you can just have documents as a serialized object graph. So it's up to you, your use case, that you define whether you want to impose a schema on top of it or not. So it's slightly flexible. Then you need to come up with a query language, because there is a document, there is a structure to it, or a semi-structure to it. You'll write your own custom query language and get going with any kind of queries you want. Now, what's the difficult part with this kind of a semi-structured approach? Complex relationships are non-trivial. Just document references will not help you traverse entire association graph. Linked document queries may not be optimized. If you are just like in SQL world, you do complex joins. Here, it's non-trivial. So you need to think of savvy ways if you're going with this kind of a model. Examples of document stores, the MongoDB, CouchDB, Couchbase, etc. So there are solutions in each of these spaces that you can explore. Let's go into the last world. Absolutely no schema. It's unstructured world where you are creating some structure which is suited to you. But by default, as a built-in feature, there is no structure to it. So what do you have in no schema approach? You just are dealing with data blobs. Relationships are not inherent. That's a second kind of a data element you introduce in this kind of a model. Queries are supported to data views, indexes, search, reverse indexing. So there are certain things that you blend together because this is a world which is unruly. But it is extremely flexible and pluggable. You can blend together so many tools and technologies that you make your things work. So advantages, it is very, very elastic. The variability of data format, secondary indices, all those can be easily supported. Even the non-functional aspects like performance are highly tunable. If you know of the CAP theorem, you can choose any of the two in most of the implementations, and you are making some known compromises based on your use cases, and these data stores help you with that. Cons, relational data is a force fit. It is really suboptimal. So more often than not, you will be introducing newer elements or newer technology stacks alongside the NoSQL stores to help you with relationship management. Plus minus, querying models are specific to stores. So it's both a positive and a negative con. So each of these data store implementations give or offer to you specific querying methodologies. The good part is, that this is specific. It will not cross the lines. They are restricting themselves to one way of querying. So if your requirements fit into that querying methodology, then you know that it is being best delivered by them in a more optimal way. The con part is you are restricted. In future, if you need to change your querying paradigm, these data stores may not be suitable. So examples of NoSQL stores, Edge-based, React, Cassandra, and there is a plethora of them. I mean, you can Google and you'll find tens of lot many coming in every single day. So far, what have we done? We have identified data elements, we have identified relationships, and we are trying to glue them together to form a logical model. So let's introduce you to a catalog data cluster. Now, each of the data elements that we just mentioned has its own independent heuristics. They have their own characteristics. Their querying patterns will be different. The way I access a catalog or a product biblio from the way I update a pricing associated with the product would be entirely different. If I'm accessing a product biblio, I know the product data, which is more around how I package the content, has a different access pattern, compliance. Then there are much more accessory data around products, recommendations, search indexes that you build on top of the product, or any user-generated content which is associated with a product, that will have a different query pattern, and the growth of that data will also be different. So let me characterize the data appropriately, bundle related set of data in terms of the query patterns into one logical cluster. So I end up having biblio data as a data node, product data, compliance, pricing, accounting, and I'm open to introducing many more data nodes into the cluster which have their own peculiar characteristics which can be solved in a much more optimal way with appropriate choice of technologies. So this entire block is my catalog data cluster. For the outside world, they don't know about the cluster, but yes, internally I have optimized it to create individual data nodes which are solving my optimalities. So on top of it, what I'll do is I'll create partitions. So internally there are partitions. I'll create view to it. I'll have interfaces, so people can go ahead, query the data, not knowing that how it has been implemented internally. And I have the flexibility behind the scenes to blend together multiple data stores. So when I choose a data store within the data node cluster, what are the things that I'll go by? Data characteristics, whether I want reliability for my data, which is more in terms of availability and redundancy. Whether I want data to be much more consistent. I can forsake availability to some extent, but I want the data to be absolutely consistent. How much of an elasticity do I want? Do I want a lot of horizontal scaling? My business is growing at a very, very rapid pace. Day 1, day 2, day 5. I see 1x, 2x, 3x kind of a growth week by week. So what kind of a horizontal scaling do I need? Then elasticity is also functional. My catalog definition may keep on changing. Can I adapt my schema with every business requirement change that is put forth in front of me? What are the querying capability I need from my data store? Do I need support for indices, free-form queries, searches? What kind of relationships I need to build? Then finally SLAs, what are the volumes I need to support, throughput, latencies? So these all help me choose an appropriate technology solution for each of the node in that data cluster. So again, what part of it is art, what part of it is science? Just be comprehensive in terms of listing down these characteristics. That's the science part of it. Be very methodical, but be unbounded by choice. Now, what we want here to be a scientist who has a color palette in hand. He has a choice of different colors, and he wants to blend it together to come up with the right solution. Everyone here, I guess, knows about the CAP theorem. So which two do we pick? So in this triangle, there is only just one node that you can pick at a time. So whether it's P or A or C or A, C or P. So many of the data stores will just impose a restriction that I can only support consistency and availability. I can't help you tune it further. But there are some data stores which say, okay, you configure the data store appropriately. If you want C and A, configure it. If you want A and P, configure it appropriately. So if you feel that your catalog management system is going to have a lot of flux in future, go for configurability. And not to be missed out are the other data points. Operational ease, tech ops or any operations team which is looking out into the infrastructure requirements, do they have enough visibility or glue into the systems? Monitoring, reporting, config management, how easy it is. At a face value, it looks all good. But if I am not able to look into it, it is a black box for me, then I'm just waiting for the doomsday to come. And on that day, I'll not be able to do anything. And pluggability with distributed computing platforms. So earlier in the slides, we mentioned that be savvy about what can be done online, what can be done offline, sync, async processing. If your data store is compatible with any distributed computing platform, I have that choice. I can one day decide to go async because sync is killing my system. Make use of the right abstractions. So like we said, at the ground level, there are a lot of plethora of tools or technologies that you have come up with. That multiple data stores that you have blended together to form the data node cluster. Now, if I choose the right abstractions, I'm shielded from any flux in the future. So this is the data. This is the data grid. So we have data 1, 2, 3, 4 grids. This forms a cluster. On top of it, we have the data access interface. Now, business can interpret the data in many ways. Pricing for some is more around compliance. Pricing for some is around accounting. Pricing for some is around what I display to the customer. So if I think from a business point of view, I have different interpretations. I need to look at the data from a different eye. So that's the view layer. Either there are pre-computed views or dynamic views, which is raw data translated into something meaningful to the business. So cataloging is one such system where it is entirely business-centric. Use cases evolve a lot, and correspondingly the views will evolve. Views have multiple interpretations of the data. We want to keep the views decoupled from the underlying data. They are loose associations that you make. So in terms of the characteristics, underlying data has to be very, very elastic, which is more in terms of the semantics and the form. So I need to be able to support the raw data evolving in terms of the structuring, schema, much more versatile. And in terms of views, they have to be very, very adaptive, either from a business point of view or from the underlying changes. Architect for scale and performance. Be very, very comprehensive in terms of what are the non-functional requirements. Identify all possible usage patterns, because those are going to help you partition the data appropriately into different data node clusters, which have a corresponding technology solutions to it. Make use of the right abstractions that shield you from any flux in the future. Choose the right tools for the job. One solution does not fit all. So just characterize your systems well enough and see which systems help you solve it well enough. Pluggability. I should not be dependent on one solution stack. If I'm, if it has become indispensable, then I have made a wrong, and later on I find out that it's a wrong choice that I've made, then it requires an overhaul of the system, which, in today's world, no one can afford. Decouple data. Data and business logic needs to be absolutely, decoupled from each other. Logic should not influence data changes, and data changes should not influence logic. Look at opportunities where you can do with offline processing, Hadoop kind of frameworks, mapper reducers, or there are many that are coming up. So distributed computing helps you a lot in pre-computing data semantics, which can be used at a later point of time in a much more optimal way. Measure, monitor, evolve. Understand that you cannot build a perfect system. Systems are by default imperfect. They keep on going towards perfection over time. So what is the best tool in our hands? It's measuring and monitoring it constantly. SLAs change, system has to be adaptive. Start off with established goals, benchmark and meet initial set goals. Changes are very, very gradual. Just look out for symptomatic things that come in front of you and react to them. Always work for towards incremental changes. Never, think of that, when things go wrong, I can overhaul the entire system. So the, uh, the training element here would be curious, have doubts, deeply introspect, and be the ultimate scientist, at least when it comes to it. Here you don't need to be an artist, here you need to be a scientist. Finally, we know change is constant. You should be ready to adapt to the changes. Requirements evolve a lot. In cataloging system, specifically, it does a lot, and mostly influenced by the business. Data interpretations grow. They vary over time. So be very flexible, be very adaptive, be very imaginative. Work as a scientist who appreciates art, and I'm sure you can work out a great cataloging system. Any questions? Sure. So granularity is pretty subjective. So if I say pricing has many elements to it. There is meta around the pricing, and there is a price value associated with it. So meta would be things like taxation based on regional, any other compliance related aspects related to the pricing. And the other part is the evaluated price. So if there are multiple systems that deal with pricing, cataloging, of course, will have the meta around the pricing. Accounting may just be dealing with the price valid at a certain point of time. So I'm good with keeping just that price as a value in the accounting software, but the meta should be there only in catalog management system. Accounting should not, start duplicating the meta, because change here, how do I replicate in real time to the accounting softwares? So be savvy about the use cases. Product biblio. So which are the other systems that you think would be dealing with product biblio? So catalog is there. Catalog should be the golden source of truth. If website is caching product biblio, that's still a cache, but I do not want it to go into the functional aspects. Caching is non-functional. If website starts storing product biblio in its database, then that for me is data duplication, and that should be avoided. Any other question?
So I have a question.
Sure.
Basically, I believe at Flipkart we sell all the products. Okay, we are from known manufacturers, and they all come with barcodes. Okay, so to address that title plus color plus edition plus publisher, okay, wouldn't that be solved by using barcode plus the manufacturer?
So where are the barcodes coming from? Are we giving the barcodes, or is the supplier giving the barcode?
I don't have any clarity on
Sure.
that. That's the reason I asked.
To answer it, so in the world of books, it becomes a bit easy. I'm not talking about digital books right now. Physical books, all the books will have ISBNs, and ISBN is a globally unique identifier for a book, and it solves a problem. If that kind of a solution gets applied to any physical product, it really solves our problem, but it's not the case.
What about like soaps and other things? Okay, soaps, detergents, let's say, those also, I believe they have a barcode. Okay, same with any CD.
Mm-hmm.
Okay. Till now I used to think, okay, they have a barcode. Okay, maybe you can give a clarity on that.
Yeah, so barcodes again are supplier. So you need to understand the world of barcodes then. Each supplier tagging a soap with a barcode. Now, I need to be very confident that in that supplier domain for a specific product, that barcode is to be unique, which would be there. But I pick two suppliers, two different soaps, and their barcodes not matching. I need to be having some kind of a confidence in the barcode generated by two different suppliers, that they are not going to overlap. For which we need compliance. And do we have compliance around barcodes? I'm not too sure. Yeah, so now we added supplier name, right? Now you get into that world where supplier name plus barcode.
At least I will not go into the color code, right?
Sorry?
Because it is all the colors and every variant of that is coming from that supplier only.
Right.
Utkarsh, also there's an assumption being made here that the supplier will provide the barcode.
Yeah, so I mean, that's what Umesh was saying, that we are assuming that barcodes are being supplied.
Right, so we can't rely on that assumption.
Exactly. Book publish. Okay, any other questions from the audience? Okay, thank you. So there was some corner discussion. We can take it offline. Okay, thank you guys.